Okay, I want to show you just a kind of an amazing example of a disconnection syndrome when you realize that you are we are processing information, coming in through either the auditory realm or the visual realm, right? And we're going to be shunting some of this meaningful, speech that's been generated by others or sign coming in visually along specific networks that are involved in the extraction of information. So the comprehension of what is being said or signed or has been written on the page, and other networks that are involved in the generation and the production of your response, or if you're repeating it, for example. So this is a particular syndrome. It's rare, luckily, but it's called pure word deafness. And what happens here is that the language networks that we've been describing, right, that are found in the left, hemisphere, this sort of posterior network that's important for, comprehension of speech, sign, whatever channel it comes in, written, letters, braille, right? And this sort of more frontal network that's involved in the production of speech or sign or, some other form of expression. You actually, if you isolate that network in the left hemisphere from access to a particular channel of information, you no longer can comprehend the information arriving through that particular channel. What I mean by channel is like speech, for example, versus visual input, like from sign. So people can have this series of small strokes that take out, first of all, the projection from the thalamus. Remember, the thalamus initially processes sensory information before sending it to particular areas of cortex. So there's a particular nucleus, or set of synapses in the thalamus that gets the information that's coming from each ear and then sends it, the axons from that thalamus, thalamic nucleus, will then project up to primary auditory cortex in the temporal lobe, right? And then, that information can then be distributed in the left hemisphere, into Wernicke's and Angula gyrus and all these other regions for comprehension. Well, if you damage the connection between the thalamus that's projecting to the left hemisphere, to the left primary auditory cortex, you don't get information coming into the language network through that route, right? The coming up, from the thalamus, into primary auditory cortex to then be distributed on the left. There's another way that information can get to that network. So you have to have a second stroke or, a second area of damage, and that is the cables, the axons that connect the right hemisphere to the left hemisphere, because you could still have information going in, to the thalamus on the right side, and then going to the right, primary auditory cortex, and then being distributed across this connection. Is a whole series of cables that go back, or go over to the, the left hemisphere, and they go back and forth. They share information between your two hemispheres. It's called the corpus callosum, and it's actually indicated on, it's like not very well, but right up here. This is the cables that connect, the gray matter right over on one hemisphere with the gray matter on the other, and vice versa. And this is showing you the cut, down below, from the thalamus up to primary auditory cortex on the left. So if this happens, you literally isolate the language network, the comprehension network at this posterior region, right, that would normally get auditory information coming through your ears. You isolate it from auditory information. So these people have this bizarre syndrome called pure word deafness. So they're not deaf. I mean, they can hear sounds. They still have a perfectly fine, ability to send information to the right hemisphere of the brain, the auditory information. But they can no longer get that auditory information over to the left hemisphere, where the language network, where the comprehension network is for language. So they hear the sounds of speech as just sounds. There's no meaning associated with them. They don't hear them as words. And over time, actually, their ability to produce language gets worse and worse and worse, because they cannot hear their own speech as words. And they can't tell if they're making errors over time in how they're generating the meaningful sounds of speech. So they tend to get less and less fluent in terms of their expression, the longer they, have this particular disorder. But what's interesting is that typically with pure word deafness, there has been no interruption of visual information into the language network. The language network is still accessible. It's still intact. This is actually a secondary aphasia, right? Because you're losing the ability to get that auditory information into the language network, but the language network is still intact, and it can still handle visually presented information. So you can read fine. You just can no longer hear the sounds of speech as meaningful speech.